The blockchain is an undeniably ingenious invention, the brainchild of a person or a group of people known by the pseudonym Satoshi Nakamoto. But since then, it has evolved into something greater. And the main question every single person is asking is, what is blockchain? By allowing digital information to be distributed but not copied, blockchain technology created the backbone of a new type of internet. Originally devised for the digital currency, Bitcoin, the tech community is now finding other potential uses for this technology. Now, blockchain is an append-only sequential data structure. In order to change a single block in the middle of an existing chain, all subsequent blocks need to be changed, making this operation computationally inefficient. Talking about the five key components of a blockchain. First is cryptography. Use of a variety of cryptographic techniques including cryptographic one-way hash functions, Merkle trees, etc. Peer-to-peer network, consensus mechanism, ledger, and validity rules. Now talking about transaction. Each transaction carries a certain amount of data. First, the public key of the sender of funds. Second, the public key of the receiver of funds. Third, the value amount of funds to be transferred. Fourth, inputs, which are references to previous transaction that prove the sender has funds to send. Fifth, outputs, which shows the amount relevant addresses received in the transaction. Sixth, a cryptographic signature that proves the owner of the address is the one sending this transaction and the data hasn't changed. Now, signatures. Signatures perform two very important tasks on our blockchain. Firstly, they allow only the owner to send their coins. Secondly, they prevent others from tampering with the submitted transaction before a new block is mined. Signatures will be verified by miners as a new transaction are added to a block.
After understanding the blockchain, we need to understand how is it verified. A chain can be verified through mining. Mining needs to be performed in order to create a new group of trustless transactions. These are also called as blocks on a distributed ledger called blockchain. Mining is a requirement to define an expensive computer calculation. You might also refer to that as proof of work. Mining serves two main purposes: to verify the legitimacy of a transaction or avoiding the so-called double spending, and to create a new digital currency by rewarding miners for performing the previous task. When you want to set a transaction, this is what happens behind the scenes. Transactions are bundled together into what we call a block. Miners verify the transaction within each block are legitimate. To do so, miners should solve mathematical puzzles known as proof of work problem. A reward is given to the first miner who solves each block problem. Verified transactions are stored in the public blockchain. From a technical point of view, mining process is an operation of inverse hashing. It determines a number so that the cryptographic hash algorithm of block data results in the less than given threshold. Another way of legitimizing a blockchain is known as proof of stake. The proof of stake we'll be explaining in the next slide.
First of all, let's start with the basic definitions. Proof of work is a protocol that has the main goal of deterring cyber attacks, such as a distributed denial of service attack, which has the purpose of exhausting the resources of a computer system by sending multiple fake requests. Proof of stake is a different way to validate transactions based and achieve the distributed consensus. It is still an algorithm and the purpose is same as of the proof of work, but the process to reach the goal is quite different. Unlike the proof of work, where the algorithm reward miners who solve mathematical problems with the goal of validating transactions and creating new blocks, with the proof of stake, the creator of a new block is chosen in a deterministic way, depending on its wealth, also defined as a stake. Whereas proof of work is also a part of mining, which we have previously learned in the video.
To create a secure chain, we need to encrypt the keys that we are doing with SHA-256 algorithm. To understand how we are doing it on a blockchain, we first need to understand blockchain came from a hash function perspective. The blockchain is a testament to the power of a single cryptographic primitive, the hash function. Really nothing else is required. So if you can get your head around the hash function, you can understand the basics of the blockchain. A cryptographic hash function takes one input and calculates one output. The output bears no obvious relationship to the input. Indeed, it looks completely random. A tiny change to the input produces a completely different output. It's impossible to find two different inputs which give the same output. For the function SHA-256, the 256 refers to the fact that the output is always the same length, actually 256 bits, independent of the length of the input. Anyone can simply change an internal transaction and recalculate the rest of the chain and claim that this is how now the valid hash chain. On the side note, hash values must be numerically smaller than a certain limit.
A part of encryption is a private and public key. The public and private key pair comprise of two uniquely related cryptographic keys, basically long random numbers. The public key is what its name suggests, public. It is made available to everyone via publicly accessible repository or directory. On the other hand, the private key must remain confidential to its respective owner. For example, if Bob wants to send sensitive data to Alice and wants to be sure that only Alice may be able to read it, he will encrypt that data with Alice's public key. Only Alice has access to her corresponding private key, and the result is only one person with the capability of decrypting and encrypted data back into its original form. As only Alice has access to her private key, it is possible that only Alice can decrypt the encrypted data. Even if someone else gains access to encrypted data, it will remain confidential as they should not have access to Alice's private key. Public key cryptography can therefore achieve confidentially.